Now we're going to convert our deployment into a stateful set. So go ahead and copy this deployment here, and we'll do -2-statefulset.yaml. This, of course, is going to be our MySQL. We could call it a deployment still, but it doesn't really make sense. So I'll just call it StatefulSet or SS if you want to make it even more simple. We change the kind to stateful set as well. And then the labels, almost everything else is almost the same. So I'll just change them all to MySQL instead of WordPress. The actual container itself, I need to change as well. This one's actually really simple. It's just, I'm going to call it MySQL container, and then a very specific version of MySQL. If you don't specify a specific version with a database, then you run the risk of getting the latest version that might not be fully compatible with all the things that you're trying to do in WordPress. Whereas this version is compatible with WordPress. So keep that in mind when you go through this. Okay, cool. So the next thing is our config map reference. Well, the current config map is made for WordPress, not for MySQL. So we need to change this a little bit. So instead of using the env from, we'll go ahead and set up env, and then we will go ahead and configure the various ones we need. So the first one is the MySQL database. And then the second one is going to be the MySQL root password. Now, I would say that you would probably want to change these things. You would want to adjust them to something a little bit better, like a different username and stuff like that. But I'm trying to keep this as simple as possible while also giving you as much benefit as possible. So these environment variables are not in config map. While it's true you could actually just copy and paste them and then duplicate them, I want them to be the exact same key value pairs that are coming in here. In other words, coming back into our environment variable here, what I want to do is say value from, and this is going to be our config map reference. And once again, we'll use that same name, which is this. And then we change the key value that we want to use, which is going to be, our DB name here. There we go. And we can do the same thing for our password. So I'll bring this in and we'll grab that password. And there we go. Okay, so we've got those things in. The port itself is no longer this HTTP port. That is just something I added off video, but you can give a name to any given port. So our stateful set port is going to be our MySQL port, which by default is 3306. Now these port values will come in handy when we provision our services, as you may be aware. But this almost feels like a deployment at this point. It basically is a deployment. It's not really any different than a deployment. So of course you should be wondering, why even use a stateful set? Well, it has everything to do with volumes. Now databases, of course, have to have persistent volumes. We need to store the database data somewhere. Otherwise, what's the point of using a database container service, right? Because the container itself is ephemeral. We can delete it at any time. But the data that we store from that container, we need to persist. So to do this, we actually declare another value in here on the same level as template. So come down in here, and we call this the volume claim templates. And I'm going to go ahead and copy and paste some stuff here. This is coming directly from the Linode Kubernetes engine documentation. But the idea being is we declare this template right here is a persistent volume claim. I give it a name. I give it a read write once, which is what the access mode that's available to us on the Linode Kubernetes engine. The storage class name is also from the Linode Kubernetes engine. And the final thing is, how big do I want it to be? In this case, 10 gigs, that's probably enough. So now that I've got this volume claim template, I can go ahead and mount this volume. So we go ahead and do volume mounts. And once again, we'll use that same exact name here. And then we are going to go ahead and give it a mount path. This is coming from the MySQL documentation. So I'll just go ahead and copy and paste those things from there. So it's their specific configuration as to where to put this volume. And so this is our stateful set now. And deployments cannot do these volume claim templates. You can mount volumes to deployments, just like we see here, but the actual claim templates cannot be mounted. So what we could do is with our replicas, if I did 10 replicas in this stateful set, it would be the same thing as also doing 10 volume claims for each replica. So each container itself has one specific volume it can run with, which is great. So one more thing that we still might want to do with the volume itself is actually clear out any data that might already be on there. Now, there's a good chance that there is no data on there, but in the case that there is data, we just do this init containers command, and we use a very small container image called Alpine, which allows me to just run this command right here to remove a folder called lost and found if it's on there. And it's on the same level as containers themselves. There are other things you can do with init containers, but this just happens to be one that's almost identical to what we do with our actual container. And this, of course, will run before our actual container runs. So with this in mind, let's do kubectl apply-f. I'll go ahead and copy the stateful set itself. We'll run that, and I get this unknown error here from our config map. So we've got value from and config map key ref, not config map ref. So let's get those correct. There we go. It's very close, but it's not quite the same. So now if I do kubectl get pods and watch them, I can see MySQL SS-0. This is another feature of config maps, is they will actually increment them 1, 2, 3, 4, and so on as far as the replicas are concerned, where the deployments do kind of pseudo-random values in here, and it's not quite logical or linear. But we see our MySQL, value is actually running. The actual stateful set and the container is actually running at this point, hopefully with the correct values. We still need to test that, of course. But at this point, we have a stateful set for our MySQL. Let's go ahead and change the replicas to 3, for example. And so if I went ahead and ran this and look for the pods, it will now do 1 at a time. So 1, 2, 3, and so on. But the idea here is what this won't do is turn this MySQL container into a cluster of MySQL databases. It doesn't work that way. This is a one-off container. It's just like running a single container with a single volume attached to it. It doesn't automatically cluster the databases in the terms of how a specific database feature would end up working in that sense. So if you're looking for database clustering, this is definitely not it. That's kind of the point. Anyway, so now that we've got our stateful set in here, I'll go back to 1, just bring it back to where we need it to be. And this should take not too long to bring everything back because it only brought up one new one. And something you might see in your volumes is multiple volumes in here now. So we really just need one volume, but it went to provision multiple because I asked for multiple, so it's going to attempt to do that. Now, when it comes to deleting these volumes and stuff like that, typically I want to make sure I know what volume I'm going to delete. So to figure that out, you can use kubectl get PVC, which stands for persistent volume claim. And this shows me all of them. It also shows me where they're coming from. So this is really the only volume that I might need, right? So the DB volume SS0, which is for that first replica. So if I come in here, I grab this and search for that one. Hopefully it's in there somewhere, or without the dash maybe, or just get those last values. So let's go ahead and get those last values. So these other 3 I don't need. Now, of course, it's already attached to one of the instances, but I just wanted to point this out because you just want to make sure that you're cleaning up some of these old volumes if Kubernetes is not doing it for you, because you can get charged for them. But yeah, that's stateful sets. We now have them. So the next thing to do is just connect everything and actually deploy a service, and then we're done. So let's go ahead and start with the ClusterIP service for our stateful set. Now, in order for our deployment, our WordPress container to actually communicate with our MySQL database container in the stateful set, we need to provision a service. So to do this, we'll do 3-service.yaml, and I'll rename the deployment to 4-. And so the service itself is going to get our API version of v1, the kind being service, and then the metadata with the name of MySQL DB. Now the service itself, I'm also going to go ahead and declare my namespace to default. Now these two things are really important, especially in a service. Now the idea here is the service name of MySQL DB will be the first part of the DNS value. We'll see what this looks like in a second, but the DNS host name, the domain name for this service, the internal domain name for this service inside of Kubernetes. Next is the actual namespace itself. So we've got our service name and our namespace .svc.cluster.local. This is the entire domain name for this service, which means that in my config map, I can actually change the DB host from just MySQL, which doesn't actually make sense here, to the actual service that I'm going to be provisioning, right? So in other words, WordPress is going to communicate to the MySQL service. Now, the service itself doesn't have the definition of where it's going to forward that request to, so that's what we still need to do. But that's exactly how this maps out. So the next thing then, of course, would be our specification, which in this case will do type of ClusterIP. Now, we have other options, right? So type of node port and type of load balancer. So both of these will expose this service on a public IP of some kind. The node port would be the public IP of the node itself, the actual virtual machine that Kubernetes is running on. The load balancer is a managed service that we'll look at very soon. So we won't look at node port, but both of those are external values for this service. The default value is an internal service. It's an internal URL, which is this. The next part of that is we need to declare the selector. What do you think the selector is? Well, it's going to be related to our MySQL selector, this one right here, which of course ends up being the pod selector, the pod label. So we go ahead and put that on there. Next up, we are wanting the port that we're going to be using. So in this case, we're going to go ahead and declare the protocol being TCP, the connection type. And then the port itself is going to be the standard MySQL port, which is 3306. If I were to change this, that would be okay. I would have to update my WordPress configuration to know about those changes. But since I'm using the default MySQL port, which we have already declared actually, but since I'm using that default, I can just stick with that and I don't need additional configuration for WordPress. Next up, our target port, and that also is 3306. Now I want to point out this right now. If you're familiar with Docker run and then the port values, this right here, this port is replacing this value. This port is replacing this value. In other words, this is the ClusterIP port, the sort of exposed, internal to the Kubernetes cluster port to the target port of inside of the container. But I can actually do this one a little bit better. And that's based off of the StatefulSet itself. I actually gave that container port a variable name. This name right here is what I can actually use instead of the hard value. That means then if I do change my StatefulSet at all to something different, then this will change as well. So if I decide that I don't want to use MySQL anymore, or I use a fork of MySQL that maybe uses a different port or something like that, but it otherwise is almost the identical thing, this service could still work. That's kind of the idea. And we'll see this again in a little bit. But with this in mind, now what I can do is, of course, run my kubectl apply, and I can do the entire folder, and that will actually configure all of these things. But before I actually do that, though, is I'm actually going to delete that entire thing because I still have one more big step, which is inside of the deployment. I need to make sure that this config map is working correctly inside of this deployment before I get that going as well. So now let's go ahead and take a look at a load balancer service for our deployment. I doubt this is going to be surprising to you, but we now want to actually access our WordPress deployment. Now to do this, that means that we need another service. So let's go ahead and create or copy our original service, and we'll do 5-service-lb this time. And I actually want to start with a node port type because we want to see what that looks like. Of course, the service name itself should be WordPress or something different than MySQL DB because we don't want to override or change that other one. This will give us this wordpress.default.svc.cluster.local. That DNS value will still be available to us even with a node port or a load balancer. So that cluster IP is still there for us, or cluster DNS really. So the next thing, of course, will be the selector itself, which is going to go based off of the deployment, which, what do you know? We already have that selector defined somewhere else. So I'll go ahead and grab that as well. I'll keep the same protocol. Next, we'll go ahead and comment out the port. Let's see what happens when we comment out the port. And then the target port itself is still that WordPress port, which is port 80. Now, if you're anything like me, you may have already done this. You go into deployment and you'll give a variable name to that container port, especially for something like HTTP port, because that's incredibly common. 80 is the common port, as we'll talk about a little bit more in a moment. So we go to that target port. We got HTTP ports there. Everything's looking good. Let's go ahead and apply all of these changes. Now, I previously deleted everything, so it recreated all this stuff all over again. But I do get an error with my service value, and that is that the port value has to be between 1 and whatever. So the idea here is this, I have to define it. But the thing about this in particular is it's going to be related to whatever this DNS value is. So right now, it's going at 3306. That's the internal value for this particular service, right? Which would actually render out the container correctly because of that HTTP port value there, the target port. Again, this is similar to Docker run P and 3306 to 80 on your local machine or wherever you use Docker run. Same sort of idea, but of course, I actually want to stick with port 80 because that makes the most sense to me. Okay, so now that we've got this, we've got a node port value. Should be correct now, so let's go ahead and run that whole thing again. Everything else wasn't changed really. The only thing that changed really was the WordPress service. So to get this service, we can do kubectl get svc or service, either one. SVC is just an abbreviation for it. And of course, we see our WordPress has this node port value and this value right here. That's an important value. But if we actually wanted to know that port value, we would go in, grab that WordPress and do out YAML. So we can see the actual manifest related to this. And we can see the port value in here as well, which is this right here. So in other words, this is actually showing us that we can declare this port value too. We can let it provision for us, or we can declare it. The question is, of course, where does this port value take us? Well, if we go to our nodes, let's go back into Linode, we've got all of these public IP addresses here, right? If I grab one of them, open it up, and then navigate over to :port, whatever that node port value is, yours most likely will not be the same as mine. This should attempt to connect to our WordPress instance. And sure enough, it does. Next, of course, if we come in and do that same thing on a different node in our cluster, guess what? It does the same thing. And you can repeat this over and over with all the instances in here. This is really cool that the node port is available in this way. But the biggest problem here is port 80. We actually want port 80. We do not want this long port. We want this one. So yeah, we could probably say the node port is 80. Let's go ahead and try that out. Let's give it a shot. We'll apply the changes. It's not letting it, right? So that's an invalid port range for the node port type. Now you might be wondering, if you aren't familiar with this process, why would I want port 80? Well, if I put a custom domain name on this IP address or any given IP address, that custom domain name automatically goes to port 80 or port 443 if it's secure. But we want at least port 80 to be working correctly, not this other one. So to do that, we must use a load balancer type. So I'm going to go ahead and get rid of that. I do not need this node port anymore. I can leave everything else the same, save it, and we'll go ahead and apply those changes now. So this does something on the cloud side. So Linode actually provisions a load balancer for us called a node balancer, And this is it right here. So this will balance traffic to our entire cluster. That is our entire Kubernetes cluster that then will balance traffic very similar to this node port service. Now, notice that it's still running. That's because I never actually got rid of that service, but I did create a new one. So if I do kubectl get svc, I got my load balancer in here, and perhaps the node port service is just provisioned funny. So let's go ahead and just do kubectl and delete svc WordPress. And that should take that down. I'm not sure why it's hanging it. Maybe it's something with my actual browser and it's just keeping it up for a little bit. But anyway, so I created another service, and at some point this will provision correctly. That IP address will actually go to the WordPress service itself. It's just going to take a moment before it's actually fully ready, which is no surprise there maybe. But the idea being that the IP address might change and all that too. So just be aware of those changes, and notice that it's at port 80 once again. And yeah, at this point, now I have the ability to have a custom domain. I could do it now. And so that's kind of where we're going to leave it, right? The next thing is I just want to test to make sure that I can actually log in and all that. And assuming that I will be able to do that, I will also test with another pod just to make sure I can connect to MySQL and stuff like that too before we call this a day.